Today I'm going to be talking about coroutines and testing, otherwise known as the talk where I put an emoji in the title and they put it in the schedule and I was like, yes! So this talk is really kind of a continuation of part of the talk we gave at Google I/O 2019, which was about coroutines on Android. It was Yi, Sergey, and me talking about the state of coroutines and some libraries that we were working on to support coroutines on Android. So the build into that, how did we get to the point that we're talking about coroutines on Android, really starts by taking a look at both the Android ecosystem and the larger ecosystems. So I have this longer coroutines talk, which has this slide here, which is all of the languages that have coroutines in the stable library. And we can see at the very beginning of programming languages, there's a brief window where people are very excited about coroutines, and then they get kind of boring for a while and no one actually pays attention to them in academia or production. And then all of a sudden, in the year 2000, we start seeing coroutines pop up in every single programming language. So almost every popular programming language today has coroutines, and there's something pretty clearly happened, something different happened in these time frames. And if you think about it, it's actually kind of straightforward. The big thing that happened was the web happened in the year 2000. So does everyone in this room actually make network requests from their Android apps? Is that a normal thing to do? So yeah, so every single person here has to do that. And that is something that coroutines is really a natural solution for, because they help you replace callbacks and express async code. And if you kind of go dig into some of the literature for some of these programming languages, you'll see this, this expression over and over again that coroutines are a natural way of expressing asynchronous I/O. And the reasons for that are manifold, but mostly it kind of simplifies our code. But if we take a look at it, we can see that coroutines give us kind of an imperative model to handle asynchronous callbacks. All of us probably started out programming in an imperative programming language. Back when we first learned how to program, we probably learned functions and for loops and if statements. A couple of people might have learned Haskell as their first language, but that's not where most people start. And callbacks tend to be a little bit harder when you're first learning how to program. Coroutines start relatively simple, right? You can make a very simple network request with coroutines, and you get a nice async behavior without having to write complex code. And when you compare them to callbacks or using objects and functions together, they're strictly more expressive. They allow you to write things in shorter amounts of code, and they provide a stronger language construct than functions and objects do for these type of problems. So that's kind of the general ecosystem. That's everything, in all of the programming languages together. And the other thing we had going into this talk was the training learnings. So at the overall, we make a Udacity course, which is basically teaching new programmers how to become Android engineers. And for that, we took a look at implementing coroutines as part of that curriculum. And when we studied what was going on with people joining the Android ecosystem, we found that developers who were coming from other ecosystems already knew coroutines, right? They were already exposed to them in JavaScript or C# or Python. So they already had experience with this technology. And we also found that novice developers who were just learning how to program and learning Android at the same time were able to pick up this concept really quickly. So that was really promising as a technology that's interesting on Android. We also ran a concurrency user research study. So this is a study of 9 professional developers who would basically keep a log of what they did in their day job when they had concurrency problems. And it focused on live data, RxJava, and coroutines. Live data, of course, is an observable data holder. RxJava is observables and schedulers and an observer. And coroutines are suspendable computations. And the results of this user research study basically said that live data was something that a lot of people liked, but they want a complete solution in this area. RxJava is powerful, but often misused and misunderstood. And coroutines seem very promising, but they need a little bit more maturation, and they potentially have a large learning curve. So one of the goals of this talk is to talk about the testing part of that. So the desired solution from the professional side really came in 3 buckets. They want something that was simple and easy to solve basic problems with, and also scaled up to handle larger problems. They wanted something comprehensive that was capable of handling all of the tasks that they were given, and robust. And by robust, that typically meant they wanted something that was testable. So at I/O, we said we're going to make coroutine first AIs, which is a recommendation. If you really love RxJava, that's not a requirement that you replace it in your application. But it's something that we're planning on adding more and more APIs that support coroutines. Most of the APIs that support coroutines, including the one we're talking about in this talk today, are alpha status. So if you want to wait 6 months, a year until these things stabilize, that seems reasonable as well. But you can expect to see more Kotlin and more coroutines coming out as supported Android APIs. So try out all of the alpha libraries, including the testing one, and give us some feedback. So today, what libraries support coroutines? We have Work Manager, which is the first stable library from Google to support coroutines with the coroutine worker. Retrofit, which isn't from Google, but everyone uses, also supports suspend functions on the services, and we'll talk about how to test those later. Room also supports suspend functions. We recently launched an alpha of the live data builder, which we'll talk about how to test later. It's basically a way to make live data from coroutines. We also launched view model scope and lifecycle scope, which are scopes that are capable of managing coroutines from a UI scope. When started, it's basically really, really useful when you want to do a fragment transaction. And then kotlinx-coroutines-test. So this talk here is all about testing. And we're going to talk about 3 different types of coroutine usage and how to test them for the rest of this talk. Fair warning, this talk is almost entirely code, so if you came to this talk hoping for pictures, I apologize. First, we're going to talk about a one-shot request, then we're going to talk about that live data builder, and then we're going to talk about how to test multiple coroutines and some of the things that can come up there. So let's dive in and take a look at this one-shot request. And I'm going to do that with just Room. So Room is a database that you can use on Android, and I'm going to use it to make the most unique to-do app that you have ever seen. This to-do app has 2 features. I can add a to-do, and I can mark a to-do as done. And these are things I'm going to implement with Room. And we're going to use coroutines throughout all of this. So in order to get started, I'm going to have to make myself an entity. So it's going to have an ID, it's going to have some text, which is the to-do item, and then it's going to mark whether it's completed true or false, so I can show that in the UI. Then I'm going to go ahead and make a to-do DAO. So here, we can see the coroutine integration with Room. So in Room, I can expose a suspend function, and that function is going to be main safe. I can just call that from the main dispatcher, and it will take care of all of the threading concerns for me. It does use a custom dispatcher, so I don't need to or really want to switch to dispatchers.io before I call the Room suspend function, or it will end up accidentally causing 2 thread switches. I'm going to make 2 things that I'm going to use in this talk. I'm going to make add item and items. Add item lets me add an item, and items gives me a list of all of the items in the database. Then now I'm going to use that database in a repository. And I'm going to make another suspend function because I want to call suspend functions. So in Kotlin, I have to use suspend functions to call other suspend functions. So here I'm going to say insert to do, and I'm going to pass it some text. And in there, I'm just going to take that text, make a to-do entity, add it to the database, and then return the new database list. One thing to note about this code, since this talk is all about testing, I'm just going to go from the very start and start using some testing best practices. I'm injecting that DAO dependency right there, and I'm just doing that with constructor injection, but we'll take a look at how that helps us simplify our tests in just a second. So I want to write a test for this class, this function right here, just insert to do. So what I want to test is when a to-do is inserted, that it gets returned. This is a very, very simple, basic test, but it has a lot of things that I'm going to have to set up in order to be able to do it. So let's take a look at that. Before we dive in, I want to talk about a little bit about test structure. So there's this pattern. It comes from behavior-driven development. Then it's become relatively popular in Android. It's called given, when, then. And basically, this pattern helps you kind of think about how to write a good test, and also helps you structure your test as you're writing it. So given is the state before the test. I'm going to set up everything that I need to do in the world in order to make it so I can run my actual test. when some action is taken, in this case I'm going to insert an item into the database, then there's going to be some expected change. And this is a pattern that if you follow, it kind of makes your test just a little bit more predictable and a little bit easier to figure out what to do where. So the first thing I'm going to do is make a variable called subject. And this is just me. This is the part about testing being art. I love to call my subject because then I can go find a test from 5 years ago and I know which class I'm actually testing in there. Because there's usually 4 or 5 different objects in a complex test. And then I'm going to make a to-do repository, and then I'm going to pass it a fake to-do DAO. I could use a mock here. I'm going to use a fake in this implementation, and then we'll come back and revisit this in a little bit. And we'll talk a little bit about what fakes and mocks are. Then for the when section, I'm just going to call subject.insertToDo. And I'm going to pass it a string learn coroutines, and then get the result back. Now, I need to note, though, insertToDo is a suspend function. And luckily, I was able to call that because run blocking test, which is marked here in the gutter well over here. And run blocking test allows me to go ahead and start a coroutine that's kind of optimized for various testing situations. So now that I've actually inserted an item into the database, I can just go ahead and use some assertions. I'm going to use cluent assertions to make sure that the world was updated in the way that I expected in my then section. So I'm going to just make sure that actual has the size of 1, and then I'm going to go ahead and test that the first element's text is learn coroutines. Now, before we move on, just a little bit of like code style. This really bugs me. So one thing we can do here, and I strongly recommend it, is to make a variable called expected that holds that string for us. So that's it. That's our first test. And there was quite a few concepts that happened in that one test case that we tried to write with coroutines, repositories, and room. So one of the big ones is this mocks versus fakes thing. Like, what is a mock? What is a fake? So at the very highest level, a mock is really a runtime implementation of a class. And a fake is maintained code that you provide for a test. And we'll dive into what these mean exactly. But there's a couple differences between these two things and the API surface they allow and what you can do with them. So with a mock, you inherently can't have any state. So this repository, or sorry, this DAO that I'm mocking inherently has state, right? It has a list of items and I add items to it that changes the list. With a fake, I can create state. Typically, mocks are bespoke and they're used in a single test case, whereas a fake is often written in a way that's reusable throughout your entire test code base. And then one of the big differences comes in how does the mock versus the fake interact with your code under test. And mocks tend to have a very high coupling to the actual code that you're testing. And we'll see a little bit about how that happens later. Whereas fakes tend to have a low coupling between the test and the implementation. On the other hand, mocks tend to require substantially less code than fakes. And fakes add actual maintained code to your code base that you have to deal with. So let's look at mocks. So let's take this test that we just wrote. We had a fake, which we haven't defined yet, and rewrite it using a mock. And let's see what happens. So the first thing I'm going to do, I'm using Mockito Kotlin. I'm going to go ahead and say, give me a mock of to-do DAO. So that instantiates a new object which exposes the interface of to-do DAO, but doesn't have any of the actual implementation of to-do DAO. If you want to know like how that works, it's actually kind of amazing and magical, and it's crazy that it works. It actually instantiates a new subclass of to-do DAO, and then magic happens. But it works. It works really, really well, and it very, very rarely breaks. And then inside of my mock using this library, I'm able to say on blocking, which is how I say I would like to provide a result from a suspending function. So on blocking items, whenever someone calls items, then do return, and then I'm going to give it a list of to-dos. So now I can go ahead and call subject.toDo repository and pass it this DAO, this mock DAO that I just created. And if I scroll down, I'm going to find something really weird. This test that I just wrote is now asserting that my mock returned the list that my test defined. So like my test is now like not really actually testing anything. So I'm testing that it should have size 1. That's trivially true. I'm testing that it should have the text that I'm expecting, which is also trivially true. So I can do a little bit better than this. I can actually verify that on that mock, the add item was called, and I can verify that the argument that was passed matched what I expected. Right, so this is much better. So let's keep going down this route and see what we can do. So we can actually verify on this mock, verify in order, which says I'd like these 2 calls to happen in order, which is quite important for the API that we have here. And I can say the first thing that must be called in this mock is add item, and it must have the text that I expect. And then the second thing that must be called is DAO.items. There's still, we'll talk about this in a second, there's still kind of like this tight coupling between the actual test code that I've written here and the function I've written. In fact, if you look at the function, it's literally the test code I just wrote. So it will run, and it's going to be successful. This is a stable test. But it does have a couple dependencies that are worth taking a look at. There's 2 dependencies that this test has at this point in time. It depends on the specific implementation of the function that's being tested. And it also depends on, and this one's a little bit less obvious, it also depends on the implementation of to-do-DAO. If to-do-DAO introduces new methods for insertion or for querying, this test could fail even though the implementation of the function under test is still completely correct. So in this case, I think a fake might be better. So let's take a look at how we can do that. So over here, we have a little fake emoji. So I'm going to go ahead and make a fake to-do-DAO. And so what is a fake? If you've never made one before, a fake is really just an implementation of a test that you write and maintain in your test code. You can go as far as creating something called a verified fake, where you publish a nice polished API that other people on your team can use. And you might consider doing this for core services, or it can be something where you just write it for a small section of your test, like I'm going to do here. And all a fake does, it's just a class. It implements the thing that it's trying to provide a fake for. And then inside of these functions, I have to provide a fake implementation of the thing that I'm providing a fake for. That's hence the name. I'm saying fake a lot because that's what this is all about. So here, I'm just going to go ahead and create a list of items added. And every time someone calls add item, I'm going to add an item to that list. And then just because I would like this API later, I'm going to provide someone who's using this fake to provide me a list of items that is the default, kind of the starting state of this fake. So this is what was in the database before the test ran. Then in items, all I have to do is take the items I was given plus the items that were added and return that. So this is all good. And now what I have to do, this is where things get a little bit more complicated with fakes. Now I have to implement mark completed. So I'm going to make another list, and I'm going to go ahead and add the items completed, add the IDs to the items completed, and filter out before I return from items, right? So you'll notice the complexity of this fake keeps getting larger as the number of APIs I support increases. And this is kind of a common pattern when you're writing fakes. Fakes can sometimes end up even more complex than the class that they're providing a fake for. So there's like some real maintenance cost to using a fake. However, given that I have this fake, it's quite reusable. I can use this everywhere in my code base. I can now write this test here, which is really what I wanted to write the entire time. Now I'm just going to go ahead and insert the items, and I'm going to get the behavior that I was expecting. And I don't have any tight coupling between the implementation of this test and the function under test. So it's kind of nice. And in this case, I would say a fake is probably a better choice. In other cases where you don't have state, a mock might be a better choice as well. So the next thing to look at, we did injection to this, and we did it with constructor arguments. Another thing that you might consider doing for this test is dependency injection or a service locator. I like to define these, perhaps a little coyly, as a big bag of singletons. And you'll notice that both of these are really the same thing. The whole goal of these things is to provide a way to either have things injected to you or look up things that are in a scope larger than the class that you're in. Huge important caveat, some of these singletons are factories, which is actually really, really important, especially when you go down the dependency injection route. Then we start getting into differences. So far, both dependency injection and service locators kind of provide us the same surface, and from a testing perspective, they provide us what we need. Dependency injection guarantees that our big bag of singletons have a dependency graph that forms a directed acyclic graph, whereas a service locator provides no static checking. And then a dependency injector is statically verifiable. So, I don't know, if you've been on Twitter recently, you're aware that we've been talking a lot about which one to use. I have a strong recommendation right now. So I think the reality is, when you look at the actual usage of these APIs, there's a difference in cost. One of them costs at setup time and at maintenance time, and the other one costs at runtime. So dependency injection typically is more complex to set up and does require kind of a little bit more maintenance and provides sometimes cryptic compiler errors. Whereas service locators tend to be easier to set up, but then they have a cost in that if you don't satisfy dependencies, there's no static checking at all. If you don't satisfy dependencies, you're going to get runtime crashes. So it really depends on what your engineering needs are and what you're trying to accomplish. So what I'm going to do in this talk is dodge the whole thing and talk about constructor injection. This is also a perfectly valid thing to do, and genuinely what I put in most of my code base, even when I'm using dependency injection or service locators. The class that calls this might use one of those to get this dependency, but then pass it using regular Kotlin syntax. And that makes my test a lot easier to write, because now I can just use a constructor call in order to write this test, and I don't have to actually deal with my dependency injector or a service locator in every single test I write. So we've managed to make it through one test. We figured out how to minimize our dependencies. We talked a little bit about mocks versus fakes. And we saw that there was a little bit of deterministic execution, and we're going to talk more about that as we go through the rest of this. So the next thing I want to go up a level, I want to talk about the view model. I'm going to use the view model scope that is it's in alpha stage right now. So view model scope is a coroutine scope that you can launch coroutines in your view model, and it automatically gets canceled whenever the view model gets uncleared. So when the user navigates away from the screen, the view model scope is going to get canceled. And I would like to use this view model scope to insert a to-do, get the new list from it, and then post that to a live data. And I want to write a test that asserts that all of this happens. So to do that, I kind of need to start dealing with the fact that viewModelScope launches on dispatchers.main by default, which is fine because all of the APIs I'm calling are main safe. But in my unit test, I don't want the main dispatcher to be dereferenced, because that's going to crash my unit test if I don't run it on device. So in order to do that, I'm going to need to inject the main dispatcher. So I can use a test coroutine dispatcher, which comes from the kotlinx-coroutines-test library, and that's the dispatcher that run blocking test uses. And then I can use that to make a test coroutine scope. And then in my setup method, I can say dispatchers.setMain. And this sets literally a global value in your test suite that will change out the main dispatcher for whatever dispatcher you passed in here. So here I'm passing test coroutine dispatcher, but I could also make a single-threaded dispatcher and pass it here if I wanted that behavior. Then in teardown, it's important that I call reset main, because again, I'm just modifying a big global variable. And then I also want to call cleanup test coroutines, because both the dispatcher and the scope are stateful objects. So if I don't call cleanup test coroutines, it's very possible to leak state between these tests. So that's a lot of boilerplate. The library kotlinx-coroutines-test is completely test runner agnostic. So you can use JUnit 4, you can use JUnit 5, you can use your custom test runner that you wrote inside your company. So whatever test runner you're using, you can use, but you might want to go ahead and wrap that all up into a JUnit 4 rule. It's a fairly short thing, and it would expose the test coroutine scoping interface. In addition, in order to finish this test, I'm going to have to use the instant task executor rule, which lets me use live data in a unit test as well. Okay, So now I have that test coroutine rule, and I'm going to go ahead and say test coroutine rule.runBlockingTest. And since I exposed the test coroutine scope on my test coroutine rule, that's actually going to use the same dispatcher that I used for dispatchers.main for my test, which is really, really convenient when I want to kind of like mix these things together like I do here. So inside this test, I'm going to go ahead and make another repository, and I can reuse that fake that I wrote for the last test, which is nice because it took a lot of code to write that thing, so I'm glad I'm not writing it again. And then I'm going to go ahead and make a couple things that I expect to be inserted. Then I'm going to do this kind of like interesting thing here that I like to do, which is observe for testing. It's a little tiny function that just observes a live data during the scope of a block. So we can go down and look at that. So it's basically just an extension function on live data, and then all it does is set up an observe forever, and then in the finally block, it removes that observer. And then after it sets up the observer, it enters the block. And this is really, really important for the live data builder, because again, the live data builder, or I actually haven't said it yet, the live data builder doesn't actually run any coroutines. I'm in the wrong part of the talk, sorry. So anyway, so now I've observed for testing so I can access the live data's value. So then I'm going to go ahead and say subject.addItem1, subject.addItem0. This code is curious to my eyes. I'm iterating over a list by like manually pulling out each element one at a time. So this is something that I think is kind of an interesting testing choice, and one that I adopted after I had an intern implement sample data. So what's going to happen 5 years from now? Someone's going to come in and they're going to take this, this expected value that I have here and replace it with a sample data. And they're probably going to do that for all tests at the same time, speaking from experience. And when they do that, they're going to go ahead and do some sort of automatic refactoring in order to replace all the places that have sample data. So it turns out 4 years ago in this imaginary timeline, someone replaced this sample data with sample data.basic-todos count 0, which is trivially true. I'm inserting 0 elements and I'm testing the default behavior of this class. So this test has been just using cycles on my CI server for 4 years. Whereas if I code it this way, this test will fail abruptly if someone replaces it with an empty list. Then moving on, I just go ahead and grab the subject.todos.value, and then I can grab those text values out of it, and then I can use should equal to make sure that it's the ones that I expected. And that runs and passes. So that's the second test. It covered how to use test coroutine dispatchers, set main, and a little bit about testing live data. So next up, let's move over to the live data builder and see how we can do that. So to motivate why we're going to use the live data builder, I would like to add a new user experience, or Nux flow, to this app. So when the user first launches this, I want to show a pop-up that says create to do and points there. Then 2 seconds later, I want to show a pop-up that says complete to do. And then I want to show get started now, or some other welcome message that's configurable from my backend. And then I'm going to use motion layout to implement that animation, which you can totally do. Just, yeah, you should definitely turn off shadows before you do that. It'll look crazy. So let's dive in and let's implement that thing. So to do this, I'm going to make myself a sealed class in Kotlin. It's the tooltips. And in there, I'm going to make 3 tooltips: the add tooltip, the completed tooltip, and then the message tooltip, which I can pass any message I want through. And then I'm going to go ahead and make a live data builder. So the live data builder is kind of a bridge between live data and coroutines. So it produces a live data. It's kind of like a coroutine builder, like launch or async, that returns a coroutine instead of some, returns a live data instead of some coroutine primitive. And it launches the coroutine when there's an observer. So that's kind of like the trick to this thing. And it cancels the coroutine when all the observers go away. So it runs the coroutine when it's observed, and it automatically cancels the coroutine. And one of the really nice parts of the live data builder is you don't have to use scopes or structure concurrency or any of the other parts of kotlinx-coroutines in order to call suspend functions with the live data builder, because it handles all of that for you. And you can emit either a single value or a stream of values from another live data, or you can build an integration from other streaming libraries. So the live data builder by default launches on dispatchers.main. You can configure that if you'd like it to go somewhere else, but here it's totally fine for it to be on main, so we're going to leave it there. And then what I can do is I can emit something from the live data builder. And emit is kind of, it's become the de facto term for this. We copied it from the flow library in kotlinx-coroutines. But basically it says, set the value of this live data to add tooltip. It's kind of important that emit is a suspend function, so it's safe to call it from a background thread, which you couldn't do with live data generally when you couldn't set the value from a background thread. Then I can call another suspend function. I can delay for 2 seconds, emit another tooltip, delay for 1 second, emit the final message, and then delay for a second. And then I want to emit null because I want to stop displaying tooltips to the user. They will probably appreciate that. So let's go ahead and take a look at how to start testing that. So the given section is pretty much the same as what we've done before, so I'm not going to talk about that anymore. But there is kind of this one interesting thing that's going on here. The live data builder doesn't do anything if no one's not observing it. The live data builder doesn't do anything when there are no observers. So in my test, if I just dereference this live data, the coroutine that it will start has not started yet. So I do need to use that observe for testing in order to actually create an observer so that the live data launches the coroutine and starts emitting values. Inside of this observe for testing, because I'm using run blocking test, everything is very deterministic here. I know the exact execution order of every single line of code here, and they'll never change. There's no possible race conditions or anything going on here. It's always going to be deterministic. I don't need to spin and wait for things. I always know which line of code is true at a time. So right away, I can say tooltip start.value should be add tooltip. And then I can advance time by 2 seconds. So this is another of the features that run blocking test provides. This allows me to use virtual time to kind of progress time in my coroutine dispatcher, my test coroutine dispatcher, without having to actually wait for the wall clock. So this test will run instantly even though it has to wait 2 seconds in real time. Then I can go ahead and use the dot value to check completed tooltip. And this is deterministic. I know that this test will always reach this line of code at the same time. There's no possible flakiness here at all. So that's a very nice thing. And then I can check that the final value was emitted as well. And then I check that null is there. And if I run that, I'm going to go ahead and see that the test passes. And that gets us to the third test. It shows us how to use the live data builder. It introduced the concept of virtual time in run blocking test. And it showed us how deterministic test code kind of helps us avoid writing those spin loops or introducing long waits inside of our test suite. So finally, I want to go talk a little bit about multiple coroutines and how to test them. So I'm going to motivate this by saying I want to get that message from the server. So this is right after the user first launched the application, but luckily my designer gave me a couple seconds of delay while the tooltips are popping around for this network request to complete. So I think I'm going to be able to build this thing. Let's see what we can do. I'm going to use retrofit, so I can make a get welcome message, and it returns a welcome message. But the important part, this is also a suspend function, so this uses coroutines as well. And retrofit exposes a main safe interface when I use coroutines. Sorry. And then I'm again going to provide a fake. To be honest, I tried to use a mock here, and I wanted it, when I was writing this talk, to show an example of using a mock. And I think it's realistic to use a mock for something like this. However, Mockito does not support the specific thing that I wanted to do here, so I had to use a fake. So what I'm going to do is make a fake suspending to-do service. And this is going to call like the weirdest line of code that I've ever seen. So what this is going to do is it's going to, in the suspend function, call suspend coroutine, which is the way you normally bridge between callbacks and coroutines. And what it does is it suspends the current coroutine until you later resume it. But I'm going to pass it an empty block, and I'm never going to later resume it. So what this ends up doing is suspending my coroutine literally forever. So this is like a thing that you're going to have to be able to do a lot when you're writing coroutine-based tests, because you have to create a way to cause a coroutine to stop executing so that you can test its behavior when it doesn't do so. So let's go ahead and Okay. So let's go ahead and write the tooltip with the message loaded from the server. So here we go. First, I'm going to go ahead and start loading that welcome message right away. So I have to make a coroutine scope so that I can launch a new coroutine. And then in there, I'm going to use async to start a coroutine I can get a result from. This is going to run kind of concurrently with the rest of this live data. So it's still on the main thread, but it's a coroutine that's going to suspend itself while the network request is continuing. Then I'm going to move on, and while that network request is going, I'm going to start emitting the add tooltip, and then wait 2 seconds. So this network request got 2 seconds to run so far. So hopefully it's going to complete. And then I'm going to give it 100 more milliseconds because I talked to my designer and that's what they decided they like. And if it returns in 100 milliseconds, I'm then going to show the welcome message. That's the goal of the design that I'm trying to implement here. So I'll do that. I'll wait for the network here. So this await call waits forever, but the with timeout will actually cause it to throw an exception. It'll get canceled after 100 milliseconds. And if it returns in that 100 millisecond window, or if it had already returned, then I'm going to go ahead and emit the message tooltip, and then wait 1 more second and emit null to stop the tooltip progression. So I want to test all of that. There's a lot going on in that live data. I've managed to pack in an entire UX into a single function. So let's see how we can test that. So I'm going to extend my to-do repository to take a service, and then I'm going to pass that fake service that I provided earlier. Then I make the subject with my repository. So everything else is pretty much the same as all the other tests we looked at. But now we're going to do something a little bit interesting. I'm not going to test every single line of code. What I'm really interested in this test is when the timeout gets triggered, I clear the live data. I want this to become null, so I stop showing tooltips. It would very much annoy the users if I did not do that. So what I'm going to do is I'm going to advance time by 2 seconds and 200 milliseconds, which is just beyond the timeout window plus the delay window that I provided. And I can run this right now. So I've provided all the code that you need to run this. And if you do run this, you'll see that the tooltip does have add tooltip right away. It's deterministic just like before. And I don't clear it. This test actually fails. It surprised me when I wrote this slide, so I kept it in. This test fails because it's still add tooltip, and I expected null. So if I ship this to production, I would show an infinite add tooltip, and everyone would probably uninstall my app. So good thing I caught it. So what's going on here? It turns out this with timeout launches a coroutine, which is going to cancel the coroutine scope, and then the coroutine scope is itself, because of structure concurrency, going to cancel the live data. And then the live data started a coroutine. That coroutine is now dead. So I'll never get to that emit null line. So this is, I didn't expect this when I wrote this slide. So I wanted to share kind of a little bit of a real situation you might run into. So I can start fixing that. The first thing I'm going to do, I used coroutine scope here. And coroutine scope always propagates cancellation up, which is a nice behavior when you want it. Right now, I really don't want it. I really want that null to get out there. So I can switch it out for a supervisor scope right here. So supervisor scope kind of provides a stop, like things don't cross the supervisor scope boundary when they get canceled as children. Then this with timeout here, this is going to have to go as well, and I'm going to replace that with the same with timeout inside a try finally block. So now I'm going to do with timeout exactly the same as before, but finally I'm going to emit null. So this is basically going to make sure that no matter what I do, I'm going to emit null on the way out of this live data. So if I execute that and the timeout triggers, it's going to go up to the try block, down to the finally, and then it's going to do the emit. So let's run the test again and see what happens. Surprise, it runs. So it tests. So this covers, this is our fourth test, and it showed us how to control timeouts and how to test timeouts and some of the issues that can come up with timeouts. It showed us how to deal with multiple coroutines in a very simple way from run blocking test. And it also accidentally showed us how to use supervisor scope, which I didn't expect to be talking about. So what's the state of this library? Super experimental. It's worth taking a look at. It's worth poking around with. Lots of people are actually using it to write tests, but there's some bugs in it too. So if you want to take a look, be sure to provide feedback on the GitHub and open issues if you find bugs. There's one known issue at the time of this talk that is not fixed that I should share with you before you use the library. So if I make another dispatcher that is a thread different than the test coroutine dispatcher, so here I'm using new fixed thread pool context. It's creating another dispatcher for me. And then I call with context on that other dispatcher. This test will always fail. It turns out we didn't write a test for this case when we made the library, ironically. So it turns out what happens here, just like to kind of dive in for a brief moment, coroutines are allowed to complete on different threads, and that's fine, and there's a whole bunch of like kind of crazy mechanisms that cause this to never become a problem in real code. But unfortunately, run blocking test doesn't call any of the functions that trigger those mechanisms. So that's going to get fixed. And there's a workaround today, which is you can just use dependency injection, service locators, or constructor injection in order to pass in the test coroutine dispatcher instead of switching to another dispatcher. So that's one way you can fix it so your code works today. And then there's a patch that's a work in progress, and this is probably going to be the final shape of it. The code's still being worked on, which is basically going to add a 30-second potential timeout after your test. So what this is going to do is if another dispatcher is still completing the coroutines that this test started, it'll provide up to 30 seconds for that dispatcher to complete. That's going to have to be a fixed timeout window because there's no real way to, like, without allowing an unbounded timeout, to allow this to continue forever. Because it is possible to suspend a coroutine indefinitely. Okay, so to wrap up, let's talk just a brief little bit at very high level about library design. What were the key goals of the run blocking test builder? The big one really was auto progression of time. There's a lot of cases in coroutines where you can call delay or you can call things that cause delay without really intending to suspend your test forever, which is what happens if you don't auto progress time. So one of the simple one is I have a suspend function has delay. I'm going to call it from a run blocking test. So what this will do is when it gets to that delay, because I'm in the run blocking test coroutine, because I'm calling a regular suspend function, it's going to automatically progress time and then continue on the next line 5 seconds later in virtual time. The other option here really would be to immediately suspend the test and then fail that test case. And it turns out this is a relatively common thing to code, so this one auto advances. Another one that is the exact same thing but a little bit more surprising is auto advancing time when you join another coroutine. This is the same behavior that run blocking has, but it's maybe a little bit surprising when you first see it. So here I'm going to call has delay, and in this has delay, I'm going to use a coroutine scope to launch a coroutine, and in that coroutine, I'm going to wait 5 seconds. So I'm like 3 levels deep in here, but this will actually implicitly join the coroutine that I launch right at the end of coroutine scope. So there's no way to return from has delay without this launched coroutine finishing. So as a result, the run blocking test has to progress time in order to make it out of has delay. If it did not progress time, again, the other option would be to suspend the coroutine forever and fail the test. So this is one that's maybe a little bit surprising when you first see it, actually. And then the other one is it will very politely auto-advance time after your test is complete. This comes up all of the time where you have a coroutine that you've tested half of it, you're done writing your test, but there's still like 7 seconds of stuff hanging out in the delays. So it's just going to go ahead and at the end of the run blocking test lambda, just progress through any time that will complete coroutines that are outstanding. This is basically to avoid failing with uncompleted coroutines all of the time. So one of the key design goals is when you finish the end of your test lambda from run blocking test, you should always fail if there's any coroutines that can't be completed by progressing time. This is because it's pretty much always like you've done something that you didn't intend to if this turns out to be a true statement. So I'm going to again use that suspend coroutine unit, like weird line of code that causes my coroutines to suspend forever. This launched coroutine will never actually terminate. So when I call uncompleted and then I return for my test will, at the end of it, have an uncompleted coroutine, throw an exception, and cause my test to fail. This is a nice safety net. So that covers everything. Thanks for coming today, and I look forward to chatting with you all about coroutines and testing.